NASA's Webb telescope stared at a patch of nearly empty sky and found galaxies that should not exist. Just 500 to 700 million years after the Big Bang, sat objects nearly as massive as the Milky Way. Astronomers nicknamed them universe breakers because there simply had not been enough time to build anything that big. Here's exactly what Webb saw, why it caused a panic, and what 4 years of follow-up revealed. Rewind to December 2021, when a 6.5-meter gold mirror unfolded a million miles from Earth. Theory was confident. The first galaxies should be faint, tiny, chaotic clumps, slowly gluing together over billions of years. Webb was built to test that, hunting infrared because expanding space stretches ancient starlight far beyond visible wavelengths. Astronomers braced for a painstaking hunt through faint smudges sitting at the absolute limit of detection. Instead, the very first batch of science data smashed the record for the most distant galaxy known. Within days of Webb's first images, in July 2022, 2 separate teams flagged the same startling object. Now called JWST, its light left roughly 355 million years after the Big Bang. And it was bright, far brighter than the faint pinprick anyone had expected from that early era. Then, in February 2023, Evo Lab's team published 6 red candidate galaxies in the journal Nature. Each appeared to hold more than 10 billion suns of stars, at just 5 to 700 million years. One seemed to pack roughly 100 billion stars into a volume 30 times smaller than our own galaxy. Headlines announced that cosmology was broken. What actually followed was stranger, and honestly far more interesting. Because the distance records kept falling. In 2024, Webb confirmed a galaxy known as JWST. Its light left us less than 300 million years after the Big Bang, and it is genuinely large. 1,600 light-years across, holding several hundred million suns worth of stars, already blazing away inside it. Lead author Stefano Carniani asked it plainly. How can nature make something this bright, this massive, this fast? Then Rohan Naidu's team at MIT pushed even further, to a galaxy at redshift 14.44. Its light left 280 million years after the Big Bang. Their paper's title called it a cosmic miracle. That galaxy is absurdly compact, only a couple of hundred light-years across, and already enriched with nitrogen. Then, in January 2026, another was confirmed, shining about 310 million years in. And that one isn't compact at all. It's an ordinary-looking, extended, star-forming galaxy, which is arguably harder to explain. But sheer brightness was only half the shock. These infant galaxies also looked chemically grown up. 2 teams aimed ALMA, a giant radio array high in Chile's Atacama Desert, at that record-holding galaxy. They detected oxygen, and roughly 10 times more heavy elements than any model allowed at that age. Astronomer Sander Schaus described it perfectly. It's like finding an adolescent where you would only expect newborns. Oxygen means entire generations of massive stars had already lived, exploded, and seeded the gas around them. Another galaxy 330 million years in was punching a hole through the cosmic hydrogen fog. Its Lyman alpha light reached us, suggesting reionization began hundreds of millions of years earlier than anyone assumed. Then Webb found something even harder to swallow, a galaxy that had already completely stopped forming stars. The Ruby survey caught it at redshift 7.3, dead within 700 million years of the Big Bang. It built more than 10 billion suns of stars, then quit. Simulations contain 100 times fewer. Geneva astronomers found 3 dust-shrouded red monsters, close to Milky Way mass, inside the first billion years. They convert gas into stars roughly twice as efficiently as ordinary galaxies have ever managed to. There's even a grand design spiral, nicknamed Zhulong 60,000 light-years wide, just a billion years after the Big Bang. In 2026, a dust-reddened galaxy turned up when the universe was only 400 million years old. Another, several times the Milky Way's mass, somehow shows no rotation whatsoever, only random stellar motion. Altogether, Webb sees up to 10 times more bright early galaxies than pre-launch models had ever predicted. So is the Big Bang wrong? No. And the answer was hiding inside Webb's strangest discovery of all. Scattered across the deep fields are hundreds of tiny, intensely red points, now nicknamed the little red dots. Their spectra revealed fast-moving hydrogen gas, the unmistakable fingerprint of matter spiraling down into a black hole. Catherine Chworowski's team showed black hole glare had inflated the mass estimates. None of them break the universe. Webb still sees roughly twice as many massive early galaxies as predicted, but that's tension, not catastrophe. In June 2026, a gravitational lens delivered the deepest red dot spectrum yet, over 40 spectral lines. Vasily Kokorev's verdict on these so-called black hole stars. Everything fits, nothing is broken, the puzzle just got better. And where galaxies truly are massive, dense metal-poor gas may have collapsed into stars before supernovae could interrupt. So the Big Bang stands. What collapsed was our assumption that the universe needed time to grow up.